Hello everyone, you are welcome to Gaia Maths Hub, a fountain of mathematics knowledge. Today we are going to explore differentiation from first principle. Have you ever wondered how fast something is changing at a particular moment? That is exactly what differentiation helps us find. Think of a function as a curved road. At any point on that road, we can draw a tangent line. A line that just touches the curve at that point. The gradient of this tangent line tells us how quickly the function is changing right there. In the graph, the curve represents the function y equal to f of x, and the point a, f of a, is where we are measuring the change. A steeper tangent line means a faster rate of change, while a flatter tangent line means the function is changing more slowly. So differentiation gives us the exact speed of change at a specific time, at a specific point. That is why differentiation are so useful in science, engineering, economics, and many other fields. Differentiation measures the change at one point at a time. Now let's talk about the gradient. The gradient measures the slope of a straight line. That's the angle of inclination to the horizontal. Okay, given 2 points on a straight line, to get the gradient, we can use y2 minus y1 over x2 minus x1. Okay, x1 y1 represent the first point and x2 y2 represent the second point. For example, for the point 2, 3 and 4 minus 7, to get the gradient, just substitute. We have m equal to minus 7 minus 3 all over 4 minus 2, which can be simplified to minus 5. So the gradient is minus 5. A negative gradient means the line goes downward from left to right. Differentiation takes this idea further. It finds the gradient of at a single point on a curve. In simple terms, differentiation tells us how fast a function is changing right now. Now, let's look at differentiation from first principle. Imagine a curve. Pick 2 points on it, one at x and another at x plus h. The line joining them is called a chord. Its slope is given by y2 minus y1 over x2 minus x1. Okay, in this case we have f of x plus h minus f of x over x plus h minus x, which can be simplified to f of x plus h minus f of x all over h. Now, as h gets smaller and smaller, the second point moves closer to the first. The chord gradually turns into a tangent line. The slope of this tangent gives the instantaneous rate of change, which is the derivative or differentiation. Mathematically, we write it as f prime of x, okay, or dy dx equal to limit when h tends to 0 of f of x plus h minus f of x all over h. For example, if y equal to 3x squared, applying this formula gives dy dx equal to 6x. Okay, for more explanation, let y equal to 3x squared. First, we are going to simplify f of x plus h minus f of x over h. Okay, what is f of x plus h? That's 3 open bracket x plus h close bracket squared minus f of x, which is 3x squared all over h. Open the brackets. We have 3x squared plus 6hx plus 3h squared minus 3x squared all over h. Okay, so we can cancel the quadratic terms. 3x squared minus 3x squared is 0. So at the end we have 6x plus 3h. Now we can go to limit. When h tends to 0, we have 6x plus 3 times 0, which is 3x. So that's dy dx equal to 6x. So differentiation from first principle is simply finding the slope of a curve at a single point by taking a limit as the gap between 2 points approaches 0. Thank you. You are welcome. Like, share, comment and subscribe.